So for multiplication of matrices, the product of two matrices, say A and B, is only possible if the number of columns in A is equal to the number of rows in B, and the result of new elements is the summation of the product of corresponding elements with regards to J and I of the rows and columns respectively. So properties of the matrix multiplication. Multiplication of matrices is not commutative. Say A multiplied by B is not equivalent to B multiplied by A. And matrix multiplication is associative if confirmability is assured. So A multiplied by BC can be written or can be possible if A multiplied by B and multiplied by C. Matrix multiplication is distributed with respect to addition. So this is distributive. And multiplication of matrix A by unit matrix is equivalent to the matrix itself. And multiplicative inverse of a matrix exists if the absolute result of matrix is not equal to 0. Then the original matrix multiplied by its transpose is equivalent to 1. So this is called also the orthogonal. If A is a square matrix, then A multiplied by A is equivalent to A squared, and the multiplication of the matrix itself by 3 times is equivalent to A cubed. And A raised to 0 multiplied by I is equal to n is equals to I, where n is positive integer. So for this example, let us get the product of A and B matrices. So here is the detailed step-by-step how to do the operation of multiplication of rows to columns that will result to new elements from multiplication. So this new element to be called A11 is the result of all the product, summation of all the product of the row 1 and column 1. So let us start here. So the rows is arranged horizontally and the column is arranged vertically. So this is row 1, 0, 1, and 2. Then the column of matrix B is 1, negative 1, and 2. And we write it here, 1, negative 1, and 2. Then, so 0 multiplied by 1 and plus 1 multiplied by negative 1 plus 2 multiplied by multiplied by 2. And here is the execution. 0 multiplied by 1 plus 1 multiplied by negative 1 and 2 multiplied by 2, and the result of this operations is the new value of new element here, that is 3. Then for the second element and row 1 to get the result of negative 2, so here this is the row 1. We will multiply it now to column 2. So this is matrix A. This is matrix A, and this is matrix B. So again, this is row 1, the value of row 1, and this is the value of row 2. So 0 again multiplied by negative 2, and 1 multiplied by 0, and 2 multiplied by negative 1. So the result is here 0 multiplied by negative 2, that is 0, and this is also 0. Then we have the remaining 2 multiplied by negative 1, and this is the result, negative 2. So if you try to multiply the row 2 to column 1, then row 2 again to column 2, then proceed to row 3 to column 1, and row 2 to column 2, and you will get the corresponding results, and this is the final answer. So we have to be careful with the signs and where to multiply the columns, the row to columns. Okay, next example. Represent each of the transformation. So these are the given equation. X is equals 3y1 plus 2y2 and xy1. Okay, so we have the wrong entry here, so there is no x here. Let's eliminate this one. Y1 is equivalent to z1 plus 2z2, and x2 is equals negative y1 plus 4y2, and y2 is equivalent to 3z1. Okay, so this is simultaneous equation, because when you expect it x1, when you expect it, we have x1 and x2. Then for the y, we have y1 and y2, and also for z1 and z1 and z2. So for x1, so we have to collect the term, the variable with the same term. So x1 and x2, we transform it into column matrix. Then x1 and x2 is represented by y1 and y2. Then another x2 and another x is y1 and y2. So the coefficient, we have to transform it into a matrix of square matrix of 2 by 2. So the coefficient of y1 is 3 and column 1. So this one. Another coefficient of y1 is negative 1. So N2 column. Then for y2, this is 2. And for another y2 is 4. So we transform it into column. Then multiply it by their variable. Then let's say that is the equation 1. Then for y1, we collect the coefficient of z. So for z1, that is 1 coefficient. For another z1, that is 3. So there is 3. So for z2, we have z2. So here. So for this equation, there is no z2, therefore make it 0 here. So this will be our equation 2. Then here, from equation 1, we will replace this term, this matrix, into its value. So rewrite the matrix containing 3, -1, 2, and 4. So rewrite it here. Then the value of y1, which is an equation 2, that is 1, 3, 2 and 0 multiplied by z1 and z2. Then proceed to the operation of multiplication and summation to get the new element. So here is row multiplied by column. So this is 3 multiplied by 1 plus 2 multiplied by 3. That is our new element in A11, A sub 11. That is 3 plus 6, that is 9. This is equivalent to 9. And for second column, second row, first row, second column, this is 3 multiplied by 2 plus 2 multiplied by 0. This is 6, and that is the result. Then -1 multiplied by column 1 multiplied by 1 plus 4 multiplied by 3. This is equivalent to 12 minus 1, that is 11. And -1 multiplied by 2 plus 4 multiplied by 0. This is -2, and that is the result. Then multiply by its variables, and we have the final matrix of 9z1, 11z1 plus 6z2, 11z1 minus 2z2. So the corresponding equation is x1, x2 is equals 9z1, 6z2, 11z1, and -2z2. So the value of x1 is the value of row 1. And the value of x2 is the value of row 2. So here, and that is the answer. So next example, determine the value of alpha, beta, and small delta for the given matrix. So when it is orthogonal, so when you say orthogonal, so the original matrix multiplied by the transpose itself is equals 1. That is orthogonal. So this is our original given matrix. We will transpose the rows into column. So column row 1 to be column 1, row 2 to be column 2, and row 3 to be column 3. And multiply it and equate it to 1. So that's why we have here the diagonal matrix with a value of 1 in its major diagonal. So that's orthogonal. So this is A and this is transpose of A. Then when you multiply it and expand the multiplication, you will have the result respectively to the 6 by 6 degree of matrix. Then equate it to 1. And we have here the value of the first element, 4 multiplied by beta square plus delta square. This should be the first element here, and this should be equals to the 1 there. And this one is raised to equivalent to 0. And this amount or this term is equivalent to the corresponding element 1. So through simultaneous equation, we can get the value of beta and delta. And using this term, which be equivalent to 1, then by substituting the result value from the first elimination, we will get the value of alpha, and this is our final answer.